Three quick examples of what it looks like to see hybrid networks from the inside. So what I'll do here for a second is I'm going to stop sharing this and I'll bring you to view of the Kadiska platform. And we're going to take a look at a couple of different elements in the platform. The first is we're going to look at the user experience side just to see what it looks like to understand quickly if a problem that is being reported is actually coming from the network, the server, or the client side. So if I take our website here at kadiska.com as an example, I'll zoom this in to make it a little easier. If I click on that, I can directly see the application performance for different users, and you can see rapidly the number of people that are connected, how long that they're using it for, and then the latency, average latency to reach our server, and how long it takes to load the full page in, and the loading progression over time. So how did it look like yesterday or earlier today? And so you can see any variation in the loading time, as well as whether there's any errors or not. So very easy to see what's going on with the server, with the application, how it's perceived in different regions. But you can also see by the service provider for remote users, which ones are having different kinds of problems. So we can easily hover over this, for example, and show that in this case, the network side, which is represented by the yellow, is actually very fast. But the problem is split over data transfer time and server response time. Here we have a problem with the user's browser where it's waiting to process, let's say something like the CSS to make sure that the page can be rendered properly. And then you have other users where, depending on how they connect, they have sometimes very long network times. 97 milliseconds to connect plus a network setup time, 75 milliseconds, for example, is too long to have a productive Teams call, for example. So we can show you quickly which networks are having the biggest problem, whether they're CASBs or SD-WANs from any one of these type of providers, for example. And then you can also see down to the user level and see who's being impacted for a specific kind of application. So if I took that as an example, it's good to see which users are being impacted and what's their reasoning for that. So this user, for example, has a very long network problem time. If we filter on them, we can also learn a little bit more about how they're using the platform and where the problems have come from. So this is really the processing times. This is their provider, and we see that they're actually located in the United States. What this tells us is we can then go and do a detailed analysis of what the network performance looks like from those locations to understand if the hybrid network is performing properly or not. So I'll show you an example of something that represents more of an SD-WAN type environment. So what we're seeing here now is all the locations around the world where we're testing with Kadiska's managed test stations, so you can see how many we have globally. But if I wanted to show you something like something that represents what SD-WAN configuration network might look like, I'll take an example of an SD-WAN that will connect together, let's say, 3 different cloud sites. And we'll take a look at that. And so you have one here in California, one in Paris, one in Sao Paulo in Brazil. And we want to see how these 3 different sites are connected together. So by selecting the 3 sites together, we'll be able to actually analyze how well they perform. And you can see there's already some loss on each one of them and a fairly long latency, which would be expected from the distance that they have to each other. And these are the kind of basic metrics that you get from an SD-WAN integrated native monitoring capability directly from the SD-WAN solution provider. It's not quite enough to know what's going wrong or why there's loss or latency, but this is the kind of information that's provided with those solutions. If we wanted to go into a deeper look and see what's happening underneath the scenes, we can do a path.performance analysis, and I'll shorten this down to, let's say, 24 hours. And what we're doing here now is we're testing from each of those locations to all the other locations. So from Sao Paulo to Paris, from Paris to California. And the reason why this took a few seconds to come up is because it's a very complex network underneath. What we're seeing here is all the different service providers, but at some point, the traffic in almost all these cases transits into the Amazon cloud network, which is what this crazy complex network is in the middle. So what I'll do to simplify this view, I'm going to reduce it down to the different autonomous systems and providers. You can see more clearly, this is all of those down to something simple. And now we can click on, let's say, California and see how California is connecting to the other 2 SD-WAN sites, or how Paris is connecting to the other 2 sites, and so on. So you can look at it from both directions and see what the performance is. And we could also look and see where the delay or the loss is in any given combination. So if I pick Paris to, let's say, Sao Paulo, you can see that the largest delay occurs here, which will be when we're moving from one service provider to the other side of the Atlantic. So very useful tools to be able to find out very quickly which routes are causing the problem, and if you have a loss between which operators, so that you can resolve that. So this is the example of sites connecting to each other, but I want to show you what it looks like to be able to do an underlay performance analysis from simply one site to a particular application. So if in this case, let's take a look at clearing these out, and I'm going to look only at one application. We'll pick, say, Dropbox, as a location is still popular with quite a few enterprises, and then we'll see how just the Dropbox where the performance is and how it looks from different locations around the world. So if I want to focus in on a particular SD-WAN site, we're going to take a look at all the different stations there, and I think what I'll do is look at one site that looks like it's having trouble in Spain. So we'll take Madrid. We have two SD-WAN underlays running here. So if I wanted to see how that SD-WAN link looked like from Madrid to Dropbox, we could do a performance analysis of that. And what you'll see here is that if you can imagine, this is actually one SD-WAN site in Madrid, and they're using two different ISP underlays to get from there to Dropbox. If you look at that, you can see one underlay is going through this service provider, Ascense, then passing to another one, the Spanish Internet Exchange, and then it's actually crossing over to Ireland, and then it's getting to Dropbox, which is hosted in Spain. So a bit of an inefficient route to go to Ireland and back to Spain when they were already in Spain. But the other underlay is actually even more significantly slow because it's passing through many different hops, through the Netherlands or through level 3 in Spain, then back. And so you can see in the end, it all converges back to the same location. If you were configuring your SD-WAN, you would pick the one that has the lowest latency. So in this case, the better performing route looks like the red one most of the time. So this is this route here. But when once in a while, there's a big spike in the red one, and then it would be actually better to pass to the first internet service provider during that time. So this would help you optimize the routing tables and the BGP policies that would impact your SD-WAN. And that this definitely helps understand also which service providers you should select to use in your SD-WAN as an underlay and whether they're performing properly or not. You can see things like this loss over here for that one particular provider was probably something that created quite a few problems and disruptions with, say, Microsoft Teams call or Zoom calls. One last thing I want to show you before we wrap up the webinar is that this is a simple scenario of what it looks like for an SD-WAN to connect through the underlays to a particular application. But it's actually not typical that this is the way it works. Normally, if I pick a different application, so in this case, I'll switch this to HubSpot, which is the CRM that we're using. We'll see a more typical behavior, which makes life even more complicated and important to be able to measure properly. I'll pick a couple of stations here. So what we know HubSpot is more than just one server. There's a number of different host names that actually are required to reach to get the different services. And this is a more typical example of what you would see from the different underlays, is that actually each underlay has to reach different hosts, the CDN, the APIs, and the application itself to make sure that the digital experience in the application performs properly. So you can see with this that it's actually far more complex than just different sites reaching one target, because if you enter into one ISP, you might actually be directed to one HubSpot API server, but if you come back later, you might be directed to a completely different API server. So this one's in Canada, for example, and this one here is also in Canada, so it's going through the Cloudflare network. If you're looking for the other ISPs, sometimes they're connecting to completely different targets. And this is what can create extreme difficulty in terms of troubleshooting issues that are happening across an SD-WAN. So this kind of tool that allows you to see the underlay quickly and have those conversations with your service provider can really truly accelerate how your teams work together and help you realize the benefits of SD-WAN in terms of cost and performance much more quickly. So that's the demo I wanted to show you in terms of SD-WAN monitoring. You can also hybrid network monitoring, just to show you how quickly you can find the problems that are impacting your users based on their digital experience that you can measure, or just based on network path and network performance.